So this is a review sheet for atomic structure and periodic table for the topics that you have been studying in the past couple of weeks in year 9. Okay, so going over here, what 3 particles make up an atom? It contains protons, neutrons and electrons. The next question then says to draw and label an atom. So I'm going to draw my positive protons and my neutral neutrons in the middle, which is called the nucleus, and then I'm going to draw my electrons in the shells outside. So that's your nucleus where your protons and your neutrons are kept. That's your shells where your electrons are kept. So let's go back. That's electron, and then proton and neutron. Okay, so then it says to name the 3 parts of the atom and to charge, mass and location in atom. So we've got positive protons, they've got a mass of 1 and they're found in the nucleus. You've got electrons, which are negative, they've got a mass that we call negligible, so it's 0. And shell, they're found in the shell. And then we've got neutrons, their charge is 0, their mass is 1 and they're found in the nucleus. Then it goes on to tell us, what does the atomic number tell us? The atomic number then, so if I was to draw out 1, remember the atomic number is the smaller number, so in this case it would be 11. Tells you the number of protons. Protons is always equal to electrons in an atom, so however many protons you've got is however many electrons you've got. What does the mass number tell you? And a nice way to think about this is the massive number, so it's always the bigger number. Tells you the number of protons plus neutrons. So to work out neutrons, you do the mass number, take away atomic number, because you already know that protons is 11 from your atomic number, so you do 23, take away 11, it'd equal 12, and that would be the number of neutrons. Okay. Where do the electrons orbit? They orbit in the shells. What is the configuration of the first 4 shells? So 2 electrons can fit in the first shell, and then 8 in all the others. You've got to remember it's 2 in the first shell. For electron configuration then, we are using its atomic number, okay? So it's atomic number, which is the smaller number. So that's something to note. So we're using the atomic number, which is the smaller number. So sodium's is 11, and then I've drawn it 2 in the first shell, 8 in the next shell, 1 in the final shell. So then I can work out it's in group 1 and period 3, because the group is always how many in the outer shell, and the period is how many shells you have. Okay, so nitrogen's atomic number is 7, so I put 2 in the first shell. Then I can do 7 take away 2, which equals 5, so then I can put 5 in the next shell. Remember to go 1, 2, 3, 4 and only pair up once you've been round once. Do it as a clock face because then it's easier for you to count and they look easier to see what's going on. Okay, so moving on up here, looking at separating mixtures. So we've got 4 ways to separate mixtures that you need to know about, quite basic ways. The first 2 you should have done loads, the second 2 may be a little bit more confusing for you. So filtration is separating liquid from an insoluble solid, so something that hasn't dissolved. We'd use a filter paper and a funnel, something like collecting water from mud. So the mud would get stuck in the filter paper up here and you'd be able to collect your water down here. Mud doesn't dissolve in water, so that's why we call it an insoluble solid. Separating a liquid from a soluble solid. So evaporation is when you've got something like salt and water and you have to heat it up. The water will evaporate off and you'll be left with the salt behind as a solid. The reason you have to do it that way, you can't filter it because it's bonded inside, it's soluble, it's dissolved in the water. Distillation then, a little bit more confusing, separating 2 liquids based on their boiling points. So you boil them both, the one with the lower boiling point then, the one with the lower boiling point will boil first, and then you can condense it through a tube and then you can collect it. Chromatography then. Chromatography is how we separate inks based on their solubility. We place the inks on a line, a pencil line, so it doesn't dissolve. place it in a beaker of water, and then what should happen as the water moves, the inks will separate into their different colours. So separating liquids such as ink based on their solubility. So moving down here to the definitions, okay. An element is something that contains only one type of atom. So if I was to draw an element, I could have hundreds of them in a row, but they'd all be the same type of atom, okay, and you find them on the periodic table. An atom is the smallest unit of matter, so they make up everything. A compound then, two types of atoms that are chemically bonded. So two different types of atoms. You could have hydrogen and oxygen. They're two different types, but they've got that bond. They aren't easily separated because they're bonded together. A mixture then is two or more types of atoms with no chemical bond. So I could have that and that together, but I can separate this one from this one because they aren't chemically bonded together. Okay, a molecule then is two or more of the same atom chemically joined. Okay, so that could be an element, but for it to be a molecule, it'd be two of the same one bonded together. So if you've just got them floating around like that, that's an element, but when they join together, they become a molecule. So we've then looked at three equations. The first one is looking at ionic compounds. So on your periodic table, you get given the charges, and then you can work out what their formula would be, okay? And we've been looking at a different method called the top spot drop, okay? Lithium fluoride is quite an easy one because they've got the same charge. So I'm going to demonstrate how to do magnesium, because magnesium is 2+ and chloride is 1+, okay? So we've got magnesium and chlorine. Put their charge at the top, but remove the actual charge. So just the numbers go at the top, okay? Then we're going to swap them. So the number that was for chlorine, we're going to swap over to the magnesium. The number that was for magnesium, we're going to swap over to the chlorine. And then we're going to drop them to the bottom. And that's how we form an ionic compound, okay? You don't actually need to include the 1, okay, because you know it's 1. But if you want to, you won't lose a mark for it, okay? So I'll also demonstrate for you E, because that's a little bit of a different one. So the same kind of thing. So calcium is 2+, so I'm just going to put the 2. Hydroxide is 1-, so I'm just going to put the 1. Okay, I'm then going to swap them around. So calcium becomes 1, hydroxide becomes 2, and then I'm going to drop them down. So calcium is 1, hydroxide, and it's the whole hydroxide, so remember your bracket, becomes 2. Okay, so I'll just put the charges for aluminium for you to have a go at, and sodium. Okay, so you can have a go at them. Obviously I've included the answers, but it's important that you also have a go. I've demonstrated 2, but you have a go. Final then calculation is something called relative formula mass, or calculating the MR. Okay, so we've got our table. Element, how many, massive number, total. Okay, so if you wanted to write them in, I've just put it a little bit shorter so it's easier for you to write out. Okay, so the elements I've got hydrogen, circle it, the number always belongs to the element in front. Elements are capital letters. So I've got hydrogen, capital letter, oxygen. I've got 2 hydrogens because of the number behind it. The mass number of hydrogen is 1, times it together, that would be 2. Okay, I've got 1 oxygen, the mass number is 16, times that 1 by 16 is 16. The MR of that equals 18. Okay, sometimes they then say, what is the percentage by mass of carbon in CH4? So going a little bit further. So you do the same thing, carbon, circle it, you've got 1 carbon, hydrogen, another capital letter, I've got 4 of them, so I can fill in these 2 sections of my table. Then I find their massive numbers on the periodic table. Carbons is 12, hydrogens is 1, times it together, so I've got 12 and 4, add it all together is 16, okay, and that's how you work out the MR, okay. So then you've got the mass of carbon, so you've got to do the total of carbon over the total mR. Okay, so it'll be 12 over 16 times by 100, and if you put that into a calculator, that should give you 75. Okay, I'm going to really quickly now run through the flame test colours, because there's something that we've been working on this term as well. So potassium gives a lilac flame, sodium gives a yellow flame, so you can write these on the back of your sheet to learn. Barium gives an apple green. Calcium then is brick red. Lithium is just red on its own. And then copper, the reason we use apple green is that copper is green, just for you to be aware. And then the gas test, which is something we've also been working on this year, relight a glowing splint. Hydrogen then is lit splint, squeaky pop. And then carbon dioxide is lime water turns cloudy. Okay, so they're the other things you need to know. You can write them on the back of your sheet. Okay.